Okay, so this should be 5.4. Zeros of polynomial functions. All right. So a zero of a function is really just a number, an x value, that makes the function equal to zero. That's why it's called a zero. And if you're looking at the graph, it's going to be the point or the points where the function crosses the x-axis or touches the x-axis, also known as x-intercept. So a zero on the graph is just going to be an x-intercept. And one thing to keep in mind, whatever the degree of the function is, that is the most zeros that the function can have. So if the degree is n, it has at most n real zeros. All right, now this I'm just going to mark out. So if we looked at number one, the degree is 3. So the largest exponent is the degree. So the most zeros this one can have is going to be 3. So we're going to use the graph to find the zeros. So that means just to find the x-intercepts on the graph. Now I whited out a bunch of stuff on here. This had us doing a lot more than just finding the zeros, and I didn't want to do all that today. Okay, so what we'll do to find the zeros using the calculator is go to y equals and type in the function. And I'm going to show you 2 ways to find the zeros. One way, we're just going to look at the graph. And on the graph, anywhere where there's an x-intercept, it is a zero of the function. So you can just count. So this one right here is at -2. So -2 is a 0, and then 0, and then 1. Not letting me move it. There we go. So you just write x equals -2, 0, and 1. Those are the zeros. Right. I'm going to show you also if you wanted to, if you're not really sure, like if it kind of looks like it crosses, but maybe it's a little bit off, you can go to the table. So if you do second graph and go to the table, any of these points where the y is 0, that's going to be a 0. So there's our -2. See y 0 here. There's our 0, and then there's our 1. So either way, you can go to the table or the graph. It's up to you. Here we go. Okay, so let's go ahead and do the next one. So we're going to take that and we're going to put it in to y equals. All right, so you guys write down what you think the zeros are. The most this one can have is 4, because that's the degree. And when we're doing zeros, we don't care about y intercepts. We only care about x intercepts. All right, so this one has x intercepts at -2, -1, 1, and 2. And that's it. That's where it touches the x-axis. Those are the zeros. Okay, so another thing that we need to be able to do is look at a function in factored form and tell the zeros. Now, on our test that we're going to have next week, part of it is going to be with a calculator and part of it is going to be without a calculator. So one thing I would want you to do without a calculator is look at look at these and tell me the zeros. And so what you do is figure out for each factor what makes it equal to 0. So I have this factor that's x. So you would say that x equals 0. And then you solve it for x. It's basically already solved for x. So one of the zeros is 0. All right, then for this one, we would say that x plus 3 equals 0. So what does x equal? -3. Whoops, sorry. All right, and then for this one, we would say that x minus 5 equals 0. And when we solve that, we get 5. All right, so that's definitely something you can do without a calculator. Do you guys see some kind of relationship between the factor and the answers? It's just the opposite sign. So as long as there's not a number in front of your x, then you just do the opposite sign, and that's going to be the 0. Okay, we're going to do that again on the next one, but we're going to add an extra concept. So a new concept for today is called multiplicity, and it sounds like it's something really difficult, but you're going to be fine. So the multiplicity of a 0 is equal to the number of times the corresponding linear factor occurs, or it's equal to the exponent on the factor. Okay, so for this first one, this first factor of x, when you just have an x and you don't have addition or subtraction or anything like that, that 0 is always going to just be 0. So you can take the time and set x equal to 0. Sometimes it's 2x, sometimes it's 2x squared or whatever. But if there's no addition or subtraction, that's going to be 0 for your 0. And then the new thing is the multiplicity. So what exponent is on this x if you can't see it? It's a 1. So that would mean this has a multiplicity of 1. All right. And then we have another 0. All right. So then we have a factor of x minus 3. So remember, for the 0, we're just going to do the opposite. So it would be 3. And then the multiplicity is going to match whatever the power is on that factor, which is 2. Right. And then I'm going to take a second and I'm going to show you what the multiplicity means for the graph. So when there's an even number, that's our power, that's our multiplicity. It does one thing. And then when there's an odd number, it does a different thing. So I'm going to type that in. Now you can type it in factored form, or you can type it in the original function. They're the same. They're just different forms. All right, so I'm going to just sketch that for a second. But if you notice, it goes all the way through at 0, which is good because we said 0 is a 0. And then at 3, it bounces. Like it touches at 3 and then goes back in the other direction. Oops. So it looks something like that. All right, so whenever there is an odd multiplicity, like there was at 0, the multiplicity is 1, then the graph crosses at that 0. It's just going to go all the way through, all the way through. But when the multiplicity is even, like at 3, that was an even multiplicity of 2 is going to bounce. So it's going to touch and then just go back in the other direction. Now, I know this is another even odd thing to remember for your test. I feel like your test is over just a whole bunch of rules this time. Not a lot of like figuring things out. It's just remembering rules, which can be difficult. But this is another even odd rule that you guys need to remember. Okay. So what we're going to do on 6 and 7 is look at the function in factored form and tell the zeros, multiplicity, and if it's going to bounce or if it's going to cross. So our first factor we have is x plus 7. So what do you think the zero is going to be for x plus 7? -7. Good. Now the next one is different. So because there's a 2 in front of that 1, it is not, in front of the x, it is not just going to be -1. So I'm going to come over and I'm going to solve it. And then you guys can decide how you want to do ones like this. So we would subtract 1 and divide by 2. So our 0 is going to be -1/2. Right, so you can do that. You can just set it equal to 0, do the 2 steps. Or if you can remember, you still do the opposite. So you still have that -1, but then you divide by the number that's in front of x. So it's up to you, however you want to do it. But this last one, because it's just x minus 4, we can do the shortcut where we just do the opposite and the 0 is 4. Okay. And then when we do the multiplicity, we're just looking at the power or the exponent that's on each of those factors. So for the -7, it's going to be 2. For -1/2, it's going to be 1. And then for 4, it's going to be 3. Okay. And then the effect, we look at the multiplicity. If it's an even multiplicity, it's going to bounce. It bounces. If it's odd, it crosses. And that's it. So this graph, we're not going to graph. I'm just going to do just like a little swiggle. We'll say -7 is here, -1/2 is here, 4 is here. At 7, it's just going to touch it and bounce back up and then go all the way through and then go all the way through. This is what bouncing looks like. Okay. We're going to do one more of those. We're learning a lot of different things today. None of it is like crazy hard, but it's a lot to do in one day. All right, so when I look at number 7 and I see this -2x squared where there's no addition or subtraction, I automatically know that 0 is 0. If you don't believe me, it's okay. You can set it equal to 0 and do all the things to solve it for x by dividing by -2 and taking the square root. But if there's an x and there's no addition or subtraction, I promise the 0 is 0, 100%. All right, then for this next one, where you have x plus 3, what do you guys think for the 0? Good. and then minus 4. Go ahead. Now, when I made this, I shouldn't have made the multiplicity match exactly what was on number 6. That's not really good teaching practice. Sorry, I didn't notice it until it's too late. But when we go back, we look at the factor, and if there's an exponent, that's the multiplicity. If there's no exponent, the multiplicity is 1. All right. And then if we write an even number for the multiplicity, we say it bounces at that point. Goodness. Sorry. It's a struggle. Spelling is hard sometimes. All right. Now, if you understand all that we just did, I think you're going to be fine on the next one because we're going to kind of go in reverse. So that we had the factors and we found the zeros. On this, we're going to have the zeros and we're going to write the factors. So we're going to, on 8, we're going to write a polynomial function that has certain zeros with certain multiplicities. So we have to call it something. So in my last class, someone wanted to call it hamburger. I didn't mean that. We didn't call it f of x or h of x or g of x or y. I just went ahead and wrote f of x. You can call it what you want to, but it doesn't need to be called a hamburger. So for a 0 of -6, so I know I have to have a factor with an x in it. So for -6, what would I do to x? Good. And then if the multiplicity is 2, what do I do? Squared. Nice. You guys are so smart. All right. And then the other factor, I have to have an x. And then if it's 2, -2. And then a multiplicity of 1, you can either write a 1 or not write a 1. I don't care. It doesn't matter to me. I usually won't write the 1 for multiplicity of 1. All right. Any questions? Okay. Your assignment is just this worksheet.